Let's jump right into this explainer with a pretty provocative thought from Nobel laureate Robert Shiller. Back in 2015, he basically asked, will machine intelligence eventually just squeeze every last drop of opportunity out of the markets? I mean, aren't we actually approaching a day when so many hyper-smart computers are crunching the data that financial markets become, well, absolutely perfect, leaving literally zero room for a human edge? Keep that in the back of your mind, because it really sets the stage for everything we're about to dig into today. Today, we're exploring exactly how artificial intelligence is causing an evolutionary paradigm shift in finance. We aren't just talking about, basic spreadsheet automation here. We're looking at how incredibly complex algorithms are out there discovering and exploiting hidden statistical inefficiencies that human beings simply can't even see. And whether you're day trading or just sitting on a 401k, this shift fundamentally impacts how money moves. Here's a quick roadmap for this explainer. First, chasing statistical inefficiencies. 2, fueling AI, features and labels. 3, the machine learning toolkit. 4, learning by trial and error. 5, old math versus neural networks. And finally, 6, the financial singularity. Section 1, chasing statistical inefficiencies. Okay, so the fundamental challenge facing any modern trading algorithm, and honestly, the reason why building these bots is the absolute holy grail for quantitative analysts, is that it goes toe-to-toe with the efficient market hypothesis. You're probably familiar with EMH. It's that bedrock theory claiming all assets are already perfectly priced based on available information. Well, AI tries to tear that down. It's hunting for systematic, exploitable anomalies, those tiny, hidden statistical inefficiencies proving the market isn't perfectly efficient after all. Section 2. Fueling AI, features and labels. But obviously, before an AI can go hunting for market anomalies, it needs fuel, and a machine learning that essentially boils down to two things: features and labels. Think of features as the input data, stuff like a debtor's income or their savings, and the labels, that's the output data the algorithm is trying to predict, like their actual creditworthiness. The machine's entire job is to figure out the hidden mathematical relationship between those features and the labels. And a handful of data points just isn't gonna cut it. To make these predictions actually work, algorithms need a massive volume and variety of data. Luckily, today, we have programmatic APIs constantly pumping this stuff in 24/7. We're talking historical data, live streaming data, structured numbers, and even unstructured alternative data like news text. This absolute explosion of data is exactly what makes an AI-first approach to finance possible. Section 3, the machine learning toolkit. All right, so we have the fuel. Now let's look at the engines. First up in the toolkit is supervised learning. This one is heavily relied upon in finance. Basically, you give the algorithm a massive sample data set where both the features and the labels are already known. You show it, say, thousands of past borrowers, and tell it exactly who defaulted and who didn't. By doing that, it learns the specific rules so it can accurately predict outcomes for completely new borrowers. Next up, we have unsupervised learning. This is where it gets really interesting because here, you only give the machine the features data. No labels, no answer key. It's just left entirely alone to find hidden structures, patterns, or clusters in the raw data without anyone telling it what it should be looking for. Think about a k-means clustering algorithm in action. It can take abstract, messy data points and mathematically sort them into distinct nearest groups. Imagine feeding an algorithm a mountain of raw market behaviors and having it automatically group assets into distinct risk categories, completely free of any human bias. It's incredibly powerful. Section 4, learning by trial and error. This brings us to our third type, reinforcement learning, or RL. Instead of learning from static, historical data, an RL algorithm learns by essentially interacting with an environment. It takes actions, gets an immediate reward or a punishment, and updates its optimal strategy, its action policy. It's literally like teaching an AI to play a video game through sheer trial and error, except in finance, a game over means losing millions of dollars. It's really fascinating when you compare this across different domains, like training an AI on Atari arcade games. Totally safe, virtual environment, zero real-world risk. Autonomous driving, on the other hand, transitions into the physical world, bringing severe physical risks. But financial trading? It sits in this unique, high-stakes middle ground. It's a purely virtual environment, so there's no physical danger, but the rewards and punishments are actual financial returns and very real financial losses. Section 5, old math versus neural networks. Now, to really appreciate just how big of a leap these modern neural networks are, we have to look back at the traditional math that used to run Wall Street. Picture an ordinary least squares regression attempting to fit a rigid straight line to sample data that is clearly curving. That straight line fundamentally struggles to capture the complex, nonlinear realities of a real-world market. Right, because traditional regression has some pretty severe limitations. It relies on fixed parameters and known closed-form mathematical equations. If the market behaved perfectly logically, great, but it doesn't. Financial markets are organic, totally chaotic, and driven by countless unseen variables. When traditional math hits these complex random data sets, it just falls short. Neural networks completely flip this script using what's called incremental learning. They don't need a predefined formula. Instead, they literally start by making completely random guesses, initializing random weights inside the network. Then, they compare that output to the true sample data. And step by step, they gradually adjust those weights to reduce the error. Over thousands of cycles, they organically adapt to fit the true shape of the data, no matter how complex it gets. Section 6. The financial singularity. So, where exactly is all this rapid evolution taking us? Well, we are currently looking at the dawn of artificial financial intelligences. We're not talking about simple code scripts anymore. These are highly adaptive trading bots, powered by deep neural networks, specifically designed to consistently generate profits above any human or institutional benchmark. They are systematically chipping away at market efficiency faster than we ever thought possible. Which leaves us with one massive, lingering question. As hardware improves and these algorithms just continuously evolve, adapt, and battle each other in the markets, is it inevitable? Are we heading straight for a financial singularity where human traders are just permanently, irreversibly outsmarted? It's a fascinating and maybe slightly terrifying new frontier. Thanks for joining me on this explainer, and keep your eyes on the data.